Investigations. Step 1. Choosing your independent and dependent variables. So, your teacher has told you that you're doing an investigation using frogs. In biology, he wants to know how heat affects them. You're going to put them in a beaker and heat them up. You suspect your teacher has ulterior motives after finding a cookbook on his desk. In physics, you're investigating how far frogs will fly when shot from a catapult. Chemistry, you investigate how high a frog will fly if strapped to a rocket propelled with Coke and Mentos. It doesn't really matter what the investigation is. It doesn't really have to have frogs in it. The first thing you always do when doing an investigation is to choose one thing you are going to change. This will be your independent variable. Then you're going to choose one thing you're going to measure or calculate from measurements. This will be your dependent variable. So, when heating up frogs, what could we change? What could be the independent variable? Well, the obvious one is changing the temperature of the water. We could have 5 iterations and heat the frog up to 20 degrees, 30, 40, 50 and then 60. We could also maybe heat them to a set temperature using different liquids to see if that makes a difference. For example, we could use pure water, salt water, cola, milk and of course gravy. What should we measure or calculate from measurements? What should be the dependent variable? Well, we could record the frog's heart rate. This would be measured in beats per minute. And you'll notice that our frog has a little heart rate monitor on and the frog's equivalent of a Fitbit, which is called a ribbit. What could we change for the catapult investigation? What would be the independent variable? Well, we could change the mass of the frog. We could get 5 different frogs. One's 0.5 kilograms, one is 1, that one's 1.5, one is 2, and one is 2.5 kilograms. What else could we change? How about the thickness of the rubber bands? This will no doubt change how far the frogs go. And you see that we've got, again, 5 iterations, 2 to 10 millimeters of thickness. What should we measure in this investigation? Or calculate from measurements? What should be the dependent variable? Well, I think the sensible one here would be distance travelled. How far will the frogs that have a different mass travel? And how far will a frog travel when fired with different thicknesses of elastic bands? What should we measure or calculate from measurements? What else could be a dependent variable? Well, we could calculate the speed of the frog. And speed, the unit of speed, is meters per second here. So you need 2 bits information. Meters, you need to know the distance. Seconds, you need to know the time. To find speed, we could time how long it takes a frog to travel 10 meters. Then we divide the distance by time. What could we change, or what could be the independent variable for the Coke and Mentos experiment? Well, we could just change the number of Mentos that you put in the bowl. We could put 1 in the first iteration, then 2, then 3, then 4, then 5. Or we could keep the Mentos the same, maybe have 5 in there, and add different volumes of cola. Say 10 centimeter cubed up to 50 centimeters cubed. What should we measure or calculate from measurements? What would be the dependent variable? Again, I think this is an obvious one. It would be the height that the ball or the frog travels upwards. And that would be measured in meters. Again, it really doesn't matter if your investigation has frogs in it or not. First thing you do, just think of as many variables to change as you can. Make a list. Then think of as many variables that you could measure or calculate from measurements. Write those down. You must choose only one variable to change. Pick one that you can change easily and accurately. It'll make life a lot easier. This will be the independent variable. Then Choose one variable to measure or to calculate from measurements, and pick one that you can measure easily and accurately. Again, this of course would be the dependent variable. And I'd like you to know that no frogs were injured during the making of this presentation. Splendid.